Derivative constant will always be 0. This is y equal to a constant function, right? The function is 13. If you were to graph that, that'd be a horizontal line through 13, right? So hopefully we all remember that. If not, you can graph it and see that. But because it's constant, the derivative of this will be 0. So let me do a couple examples for constants, and we'll just mix them up. Not a big idea. No, not a big deal. So this is 3.2. Finally got some new pens. There we go. All right, so the derivative of any constant is 0. So for example, find the derivative. Let's do a few of them just so you get the point. Find the derivative of the following. So part A, f of x equals to number 13, right? That's what they had. Or if they write it this way, y equals to 13, that's the same thing, right? We know the functional notation at this point. Oops, somebody's waiting in the waiting room. There we go. So the derivative can be denoted as f prime. That will be equal to 0 because it's constant. Or you could write it as y prime, which is equal to 0. Another way you could technically write it is using the Leibniz notation. The book may use this as well. Let me see if I can dim this bright light a little bit. I guess I can't. Well, do this. Yeah. Oh well, I'll just have to adjust.
Maybe like point it at an angle or something.
Yeah, that's what I'm trying to do.
Let me guess, the light's attached to the camera?
Yeah, it is. So
oh, look, that's good right there.
Here?
Yeah.
Yeah, we can roughly see it.
All right, cool. Yeah, I don't want you guys to be blinded on one spot.
No, it's always been like that. There's always one or two letters we can never see, but we can get the gist of it.
Professor, the derivative of my constant?
Of any constant is 0. The derivative of any constant is 0. That's the rule that I'm going to go over right now. Okay, so if they write d dx of some function, y, it's a brand new pen. Why is it being stupid? Might have to switch. There we go.
Yeah, they take a second to get everything out.
Or d dx of y, that's the same as saying dy, dx. Okay, so if you see any of these notations, it's the same thing. This right here, d dx of y means take the derivative with respect to x of y. This means you kind of already done it. It's the same thing. Derivative of y with respect to x. Y prime is basically the same thing. It's just a shorthand, but they don't tell you which variable they're talking about. It's kind of implied. Since this is all one-dimensional derivatives, we usually go with the independent variable. So, for example, well, I'll do that in a minute, I guess. Let me stick to one idea at a time. I just want to make sure, because if you're looking at the book or the videos, they'll use different notation. Also, the homework will start to use different things. I want to make sure you understand all of them. All right, so that's the first example. There's just some side notes here. Now, the derivative of y equals to 3/4. What would that be? I might have to switch pins pretty soon.
Zero? No.
It would just be 0, right?
Yeah, right? It doesn't matter what kind of number it is. It's going to be 0. Right? It's not a trick question. If they say y is equal to pi, what is the derivative?
Zero.
0, because pi is a number, right? So if it's any kind of number, there is no variable, you will always say 0. Okay. Are there any questions about derivatives of constants? And if you're wondering why, it's because derivatives are related to rates of change, and constants are constant, so there is no change, therefore 0, right? You can relate it back to real life stuff, or graphics, or graphical, or graphs of the functions, that type of stuff. So let's go back to these examples. As you can see, derivative of this constant is 0. Doesn't matter how big the number is, still 0. But over here, we start getting back to power rules. So let's do a couple of rational expressions. Let me switch pens because that's pissing me off. Okay, apparently.
Jump by with the.
What's up?
Oh, I was talking to myself. I was
Oh.
like, I don't know if that's my email.
No, it's okay. Now, example 2, same thing. Find the derivative, right? Apparently, I have to start writing with something else. Find the derivative. Man, I guess the black one was better after all.
Yeah, black ones tend to show up better on screen. Take it from a guy with experience.
Well, the issue is none of them are writing correctly. Usually they start writing by now. So I might
Yeah,
just switch to a different
Well,
pack.
when you do the off-brand ones, like I'm sure Albert purchased for you, in my experience, they take a while to start working.
I don't know
Plus,
if
they also
them-
don't like the cold.
They're not off-brand. They're the same ones.
Okay, then in that case, I don't know what's going on. But
Yeah,
I
I
also
don't-
know the pins don't like the cold because it's gel.
Yeah,
Because they're
maybe they froze somewhere. Who knows? Might.
Because I've had trouble getting them to write in the middle of spring or early spring and late fall. So like I typically walk around with one in my pocket in the Rocketbook Pocket version that I used to write notes with whenever I'm at like auctions and stuff. So I went to an auction one time and I couldn't get it to write, and so I took my lighter and went up to the pin tip and managed to melt the gel ink.
Yeah. It could just be solidifying. But whatever. We'll figure it out.
Lick it or like wet it or something.
It's a nice little, it's a neat little trick. I recommend anybody who has office supplies to know it.
And the derivative. The blue one's working good.
Please.
Of the function. All right, so pretty much all the questions will have the same instructions. Yeah, this one's writing pretty. Okay. So we'll make a few examples. F of x will be equal to. So let's do just a simple.
Just heat it
Start
up a
with
little
the-
bit and it works.
Start with square root x. All right. So remember the power rule we talked about, right? So in order to do this, you're going to have to rewrite the problem equal to x to the 1/2 because it's a square root, right? Remember this property from algebra?
Roughly.
So if it's a square root, then it's going to be a half power. So whatever, let me rewrite the rule just in case you don't remember your algebra or you forgot, not a big deal. So if you have the nth root of x, that can be rewritten as x to the 1/n. Doesn't matter what number it is or what root it is. If it's cube root, 6 root, you just do 1 over that number. 6, 1 over 2, 1 over whatever. That's where this came from. So the derivative will simply be the power rule, right? I believe we've mentioned this already, but just in case it's been a while, here we go. So bring down the power, subtract 1, and here we go. Now, you guys remember?
Yes.
Okay. So this example here that they have, we'll go ahead and do this one. They have an ugly one. They write f equal to 1/8 root of x. So same deal. One over 8. Just rewrite it. Okay. You guys see that? So same deal. Bring down the 1/8. Hold on a second. Now this pen's giving up on me.
Are those the ones that the school gave you?
Yeah, man. They're brand new. They even made a drive too for this. These pins. That's right. We got a couple packs. No worries. There we go. Might be something on my paper for all I know. There was in my
That is
trunk.
possible, because if the paper, those things have a tricky temperature. Sometimes if you if the paper is too hot, they won't stick. The ink won't stick.
Yeah. All right, give me 1 second. I got a couple
When you're in
packs.
Yeah, when you're in controlled conditions, these things work amazingly. But otherwise, they don't.
Think you're still muted.
No, he's not muted. He's just not speaking. Or unless his mic came unplugged.
Yeah, can you hear me?
Yeah.
Yeah, we got you.
All
Now
right,
we
cool.
can.
Cool. Yeah, I think I hit the mute button on my mic. Okay, so I'm gonna try this page and see if this pen works. How long this pen works, and if it doesn't work, I'm just gonna go to sleep and call it a night. But here we
That
go.
works.
1/8 root of x. Use the algebra technique. Change to a fractional power, and then do the power rule, right? And we've talked about power rule already. So the derivative will be 1/8. Bring down the power, and then you subtract by 1. But what is 1/8 minus 1? That's going to be a negative, right? So 1/8 minus 1 will be 1/8 minus 8/8. So that is a negative what?
7/8.
Yeah, so we'll have 1/8 x to the negative 7/8. That's what you guys said, right? So at that point we've done the derivative. So the homework's going to want you to change it to a positive power. And we know from algebra that if you bring that to the bottom of a fraction, because technically there is always a number 1 down here, right? Although the 8's technically down there too, but this is not wrong, it's just weird. Let me erase that. I don't want to confuse you. But anyway, so bring the x down to the bottom. with the 8. So it'll be x to the 7/8. Okay, so we brought this power down to the bottom. Is there any questions on what we did? So backtrack here a little bit. We use this property. We changed a square root into a fraction of power because that is the same thing. We had 8th root x, and we did our power rule. That's all we did. So the homework is going to want you to put it in this form, okay? Not the negative power. They'll probably tell you it's wrong or it's in the incorrect form or something like that. You see how they have it down here? All right. Okay, so the next one is basically the derivative of multiple parts. We might have done it a little bit already. They're this time they're kind of focusing on it and making you use the power rules. Before they were trying to get you to use the limit rule. Do you remember? So example 2 here, or 3. Use the rules. Sorry, let me write that better.
Throw them away. Throw them away.
Pretty much, man.
And the bad luck continues.
Yeah, it's been a horrible week, that's for sure.
It's been a horrible 2 years.
Yeah, yeah, well, it is also true.
That's why I said I'm willing to bet this entire decade is going to be something wrong with it.
Maybe this is just the world we live in now.
In that case, can someone just shoot me now?
This is normal from now on.
This is in no way normal. Felipe, that's funny.
But if something doesn't change, then it becomes normal, right? This is just how it is.
I guess so, something like that.
Although that is a very cynic and negative attitude. I'm not serious, guys. Okay. Yeah, you know what? I'm just gonna go trash all of this stuff. Okay. Let me try regular paper. Let's do that.
Let's go back to the basics.
Yeah, let's go back to basics. Good idea. All right.
What a difference.
Isn't that beautiful?
Hey, that's like cleaning.
Told you that stuff can be finicky.
All right.
Once you get it tuned in, you get used to it. It's not so bad. But
Basic differentiation. And rates of change. Okay. So we did the constants, we did the square roots. Let's see what was next. Okay. I believe it was example 3, right? I don't remember. Use the differentiation rules to find the derivative. So basically, if your function has many terms, you just you do the derivative on all the terms. So for example, let's say your f of x is equal to 7x plus 5. F prime will simply be the derivative of this term plus the derivative of this term, which is 7 plus 0, right? So it's just 7. Do another one. Another way they might write this is they say y is equal to 3x squared plus 2x plus 1. If they say find d dx of y, that means you're going to do d dx of all these terms. Which is the same as writing a prime on each term. Because this becomes dy dx, which is the derivative of y with respect to x, which is the same as saying y prime, which is the same as finding this derivative. So d dx of every single term. And I'm doing this just so you get comfortable with the notation, because a lot of this becomes difficult because you don't know what the heck they're saying, not because you don't know what to do. Does that make sense? So this is telling you, take the derivative of the first term. So what's this derivative? What is dy dx?
6x.
Yeah, that'll just simply be 6x. Now derivative of 2x.
2.
Yeah, it's just 2, right? And then the constant, of course, 0. So the derivative of y with respect to x is going to be 6x plus 2. But you see how this notation looks confusing, but it's the same thing, right? The same thing we did here. You just do the derivative of each term. So no matter how we write it, dy dx is the same as y prime, which means find the derivative of every single term. Does that make sense to everyone?
For the most part, yeah.
Let me know if I lose you at some point. So that's pretty much the power rule. The power rule will apply for the square root functions and the power functions, the polynomials, basically. And then you have the constant rule. So far we talked about derivative of a constant, derivative of a power or polynomial type thing, and what to do when you have multiple terms. Okay, also the roots.
So, where did you get the 6x from? I don't know.
Oh, I didn't show the step.
Multiply?
Yeah, you bring the 2 down, right? And then you multiply by 3.
Okay.
So the step I didn't show would be, bring down the 2 times the 3 times the x. Oh, shoot. Forgot the 2. Anyway, that makes sense.
Yes.
All right.
Oh, okay. I know where you get the 2. Okay. So you put the exponent in the front of the number 3.
Yeah. That's
Right.
you just whatever you just bring it, whatever's in front, you multiply with the exponent you bring down. That's
Yeah.
always going to be that way.
And you subtract the number 2, number 1, 1 from the exponent, right?
Right.
Okay. All right. I got it.
You're correct. So in this example, you do the same thing, right? Derivative of 6t squared would be 2 times 6, right? Which is
Yes.
12. And then you subtract 1, leaving you with 12t. Then you do this one, derivative of 8t. Well, the power becomes 0, so it's just a negative 8.
Right there on your answer, sorry to interrupt.
No, what's up, man?
12 dot, which is times. See?
Yeah, so
What?
over here when I wrote 6x, that's technically 6 times x, but we don't really write it.
But the computer will count it wrong if I don't put that times.
No, it should understand both. If it does get it wrong, then I'm gonna get new software, and this is stupid. It should know better. But let me know.
You're
if that
talking
happens.
about it like an unruly child.
Yeah, I'm just gonna abandon it in the woods.
Can you go back to your number 6 there?
Yeah, what's up?
So then that -6, that's just going to turn into a 0.
Yeah, the derivative of constant is gone, so they don't even put the 0 here.
Okay. So would it be safe to say just kind of mentally already just take that out?
Yeah, if they ask for a derivative, just know that that constant was going to be gone.
Okay.
Okay. We talked about derivatives of trig functions. I don't remember. It's been a while. Like these types of trigs.
On terms of derivatives.
No. Well, let me give you, I guess, a quick formula page. Apparently, I was using this for something. Whatever. Okay. So, oh yeah, here we go. So I'm just gonna make a quick side note here. Derivatives. And I'm gonna send you a PDF file with all the rules and properties, okay? So you don't have to worry about it. So you have it all in one place. But I'm gonna write them here just so you know. If y is equal to sine, the derivative, y prime, will be cosine. Okay. If y, so number 1, number 2, they switch back because you can't see that well. Number 2, if y is equal to cosine, the derivative will be negative sine. Number 3, these are the ones that I would recommend memorizing, but I will not force you to. You can have them with you anytime you want. But you do these so much, eventually they kind of stick in your head because they'll come up in Cal 2 and physics, and depending on where you're going, maybe other places. Anyway, f is equal to tangent, derivative will be equal to secant squared x. If your function is equal to secant x, then the derivative of secant will be secant x tangent x. And all of these are derived using the limit rule. If you're curious on where they came from, apply the limit idea to this, and you'll find this. You'll have to use all your limit properties, your algebra, and your pre-cal to figure out where these came from. If you don't feel like doing that, then I am not going to judge you. If you want to see it, let me know. All right, derivative of cosecant. The derivative will be negative cosecant x cotangent x. These are all the ones we need, right? I got the, what am I missing one? Sine, cosine, tangent, secant, cosecant. Oh yeah, cotangent. Oh, there should be 6. All right, derivative of cotan will be negative cosecant squared x. All right, so knowing all this, we can do the example that I have here in the homework. Example 4, I think. One second. All right, so let's see here. Part A would be similar to this example. Y is equal to pi over 8 sine of theta minus sine of theta.
Can you
So what-
scroll
Yeah.
back? Okay, thank you.
What is the derivative of y with respect to theta? In other words, what is y prime? So the derivative of sine, we just wrote it up top, right? It's going to be cosine, right?
Cosine x.
So we have theta, so we'll put cosine theta. That number in the front makes no difference. It's just a number, right? Derivative of sine, we just said, is cosine. That minus stays there. Now, if we have y equal to 8, I'm going to change from this notation back and forth until you get used to it, because you need to know both. As much as I want to be lazy and write y and y prime all the time, it's not good for you. All right, so y is equal to 8 plus 2 sine x. So this time, what is the derivative of y with respect to x? Right, well, this is what? A constant, right?
Mhm.
So that will be
Zero.
0. Derivative of sine? What is derivative of sine?
Cosine.
Y prime cosine x.
Yeah, so it'll be cosine x. The 2 is just along for the ride. Makes no difference because it's a constant. If this was like a 2x in front, then it's a different story. But it's just a 2, no big deal. All right, so that's basically how you do these type. See how they just take derivative of sine, get cosine, derivative of sine, cosine. The signs didn't change because derivative of sine is not a negative cosine. If it was, then you'd have sign changes. For example, let me do one just to show you. For example, let's say y is equal to negative 5 cosine x. What would be the derivative?
Sine x.
Right.
It's
Derivative of cosine.
negative.
It's negative sign. So this
Cosine.
comes with an extra negative with it. See what I mean?
Mhm.
So the negative 5 is still waiting for you, but this becomes negative sine x. So negative 5 times negative sine is positive 5 sine x. Does that make sense?
Mhm.
So look out for that, and they might come up in your homework. Okay. So this is the trig derivatives. You're going to see these over and over again. I will give you a formula sheet soon.
Can you go back to the last example you showed?
Yeah, 1 second.
Please.
There's no rush here.
Thank you.
No worries.
Cosine. Hey,
All right.
okay.
Okay.
Yeah.
So let me give you another rule. Derivatives of e to the x. So this is another special one, just like the trig ones. So the derivative of e is always itself. So if your function, I think we're example 5 now, I don't remember. If your function is equal to e to the x, the derivative of f of x will be equal to itself. Okay. Now, well, I'll put the example down here, I guess. This is the rule. So find the derivative of the following. Okay. So part A, let's say your function is equal to 3e to the x plus tangent. What is the derivative? Y prime or dy dx? Same question. Tangent x. I wrote that ugly, but oh well, you know what I'm saying, right? So the derivative of e to the x is not going to change. That 3 doesn't do anything, just like it did earlier with just like the coefficient earlier with the sine and cosine. This will simply be itself. Those are the easiest derivatives because they don't change. So then, I'll get to your question, Chris Shaw, in a second. Derivative of tangent is going to be, right, what did we say? Secant squared. So this will simply be secant squared x. Okay. So the e doesn't really do anything. So like even if it's a fraction, something like, let's say y is equal to 3/5 ex plus sine, 7 sine. I'm just making up questions here. Right. Derivative of y. This doesn't change. It's going to be the same deal. Don't let the fraction bother you. This will be similar like the last question. It will be 7 cosine x. You guys have any questions about e or the trig function so far? And I'll go back to, if not, I'm going to go back to another question.
I think we're good. I'm good at least.
I guess let me know if you're not good. Okay, so someone had a question over here.
Oh.
I'm sorry.
On number 7, I had the exact same question as you, and I got the same answer, but I try to put it into the, like whenever I try to type it in, it keeps counting it wrong.
This
I
one?
don't know why. Yeah.
What did you type in?
The exact same thing.
Maybe you put too many parentheses. Did you have theta or x?
No, it's the exact same.
You can show me.
Yes, yeah, theta is it's marked on the constant in the color.
You want to share a screen, Zuleika?
Oh yeah. Yeah, so you can see like that. I did it the exact.
Well, yours is cosine on top. So you need to do the derivative of cosine.
Oh, okay.
You see it?
Yeah.
So that would be
Okay.
negative sine. So the answer should be plus sine theta at the end, right there.
Okay.
Honestly, that was, yeah. That was throwing me off. Yeah, say that's. I only have one. Yes, I'm.
Okay.
I have a 9 instead of an 8. But yeah, that's what I have.
Thanks,
No
Professor.
worries. Yeah, no worries.
Taylor.
All right. So Prashant, derivative of cosine is going to be a negative sign. See how it switches? So then this negative times negative makes it a positive 5 sign. That's the only reason why it changed. Okay. Does that make sense? Okay. Okay.
I'm having trouble. Like, I was throwing some of these in like the homework at the same time, and I'm trying to enter one just like hers, but it's not coming out. Right.
Yeah, you wanna show me real quick, or is it a different one, or you don't have it up?
Well, it's actually a homework. No, I have it up.
Okay. Feel free. I'll check it out. Number 9, or
Number 7.
derivative of cosine is negative sine. Derivative of cosine is negative, so that one's plus. They probably want that minus in front because you have it as it's kind of improper.
Yeah, I tried that as well in front of the pi.
Could it be he's using X and not theta?
Yeah, that too. That has to be theta.
Oh, that's probably why.
Yeah,
Okay.
that's the reason. Thanks, Tyler.
Okay. Thank you.
Uh-huh.
All right.
Yeah. The thetas are not going to change across that problem. They're marked on the thing as constants across all the problems. You can tell by the color of the font. Whenever you see anything that's typed in red, is going to change. It's variable across the platform, so to speak. Anything that's written in black is going to be the same across all questions.
I think that's pretty much it here. If you guys have any questions about, in general, 3.2, if not, I'm gonna let people ask about 3.1.
I'm stuck on a few problems on 3.2, but we can come back to that.
On 23 on 3.2. That's the last one I can do.
The last one?
Yeah, the very last one.
Okay. Determine if the points, if any, which the graph of the function has horizontal tangent lines. Well, we know that the derivative we talked about, well, maybe, hopefully you guys remember, we said that the derivative as a function gives you slopes if you plug in values, right? Remember how we said that? So horizontal tangent is implying that the slope is 0. So the question is really saying, determine the points where this function has a derivative equal to 0. So you got to take the derivative of this function and then set it equal to 0 and solve for x. That's what you have to do.
Oh, okay.
And there's nothing else to it.
Number 11.
11 here. You got to bring this power up top and then do the derivative. So here, we can do that one real quick. Where's my pencil at? So basically, I'll just make up a question real quick. If y is equal to, doesn't really matter what's on top, 7 over 2x to the 2, you have to rewrite it as 7 times 2x to the negative 2. Actually, we should pull out that number first. Yeah. Yeah, there's one extra step before that. 'Cause what we can do to make this easier, because this is starting to get to an idea that requires a more advanced rule, but you can still kind of avoid it. Because you can apply this power. Let's say it's, I don't know, cube, right? Who cares? So I can apply the cube on both pieces. So it'd be 2 cubed x cubed, which is going to be 7 over 8 x cubed, right? So then you just bring up the number up top. So it'd be 7x to the negative 3. And then you just do a power rule on this guy. So you would get negative 3 times 7/8 minus 1. So it becomes a negative 4. So it's the same rule that we've talked about, but this one requires you to do extra algebra here. So on your numbers, it's the same thing. You apply the 5 on the 2, apply the 5 on the x. That's where the 32 comes from. Then you bring the x to the top and do a power rule. That's it.
Okay.
Alrighty, let's see. You guys have any other questions on 3.2?
Not that I can.
You guys have homework questions that after you worked on it and struggled on 3.1.
Yeah, 3.1. Let me pull that up. I have a few on 3.1. I'm gonna try and work 3.2 tomorrow, and I might ask a few questions on Wednesday. But
Yeah, I want you to try it out first before, you know.
Can you go back to
Yeah.
the previous page?
Yeah. This part?
No, the other one, where
Oh,
you have
okay.
all the rules.
Sure, sure.
That one. Just give me 1 second.
Let me find the derivative rules for you. See if I can while I wait for people.
question 13 on 3.1.
Now, this is a good one.
Mm-hmm.
Hold on a second.
Okay, sir. Thank you.
No worries.
There's that string of problems, 13, 14, 15, and 16. Somehow they're a little, I can't quite figure them all out.
Okay, we'll do a couple. Which one do you want to do first? Which one gave you the most
I guess
trouble?
13, because I'm 13, I guess, because I'm completely lost.
All right, let me get there. Three, 1, 13.
Mm-hmm. Delta X, if I'm not mistaken.
Just find the limit of f prime of c for a function x and the number c. Find f of x and c. It's a weird question, but it's not a hard one. It's just a really strange one.
Mm-hmm.
So
The deltas was throwing me off.
remember how on the notes we used f of x plus h? This is their h. That's all this is. They're using a different notation. Let me see if I have my book on me. It's 3.1, so I can show you what notation they're using.
That's where I was getting thrown off because I was treating something differently.
Yeah. Yeah, I don't like using the delta x because it gets confused with x, and I don't like that.
So if you substituted it for something like G or H, it wouldn't.
Yeah, it's a little bit easier to follow. Let's see here. Okay. Where the hell is it? Here. So, yeah, there it is. Do you see this, or is it too far away?
Yeah, I can see it.
So f of x plus delta x, right? We use f of x plus h minus f of x over h. So this is just the same notation as the limit rule to find the derivative. So on this question, they're doing something similar, except they're plugging in a value. They're using this with a specific x. So basically, instead of having just an x here, they plugged in a number. And instead of an h, they have delta x. That's it.
Okay, so I can substitute the delta for, like I said, an H, and it should theoretically come out with the right answer.
Actually, you just have to work backwards. You have to figure out what function did they use to get this nonsense, right? So
Okay.
8 is the function, 8 minus 2x. So 8 minus 2, and then they plug this junk in there. This is my x plus h, right? So the x that they chose is 1. So this is giving you the hint. What is the function? Well, it's 8 minus 2x. That's what this is. So if we work the other way, the way we did it in class last time, this is basically what they're doing here.
Okay, yeah, it's just the fact that it's delta, it's throwing me off.
Professor, can we download a copy of the ebook or no?
I mean, you can access it through the website, but I don't know if you can have your own copy.
I've tried. I can't quite get it to download.
I'm not familiar though. I don't know if you can. I'm sure you can steal it from somewhere, but I'm not gonna help you do that.
I haven't found anywhere to get it, so.
All right. Well, if Tyler finds it, I'm sure he can share it with everybody without me knowing. That'd be cool. All right, so this is what.
Well, if I found it, someone would have to have anybody to access it would have to have an Onion browser.
All right, here. All right, so if f is equal to 8 minus 2x, what they're saying is, okay, let's take the limit as f of 1 plus delta x goes to 0 minus f of delta x over delta x. All right, so if we were trying to find the derivative at a particular c, you would do this. Okay. So then plugging all that in, you would get the limit as x approaches 0 of, plug this into the x, right? So you're going to get 8 minus 2 times 1 plus delta x minus 8 minus 2x over delta x. And then you fix the top part. So 8 minus 8, those are going to be gone, right? So yeah, how this will be canceled, correct?
Yeah, I think so.
So it'll be 8 minus 2 times the stuff, 1 plus delta x. So it'll be minus 8 plus 2x.
Okay.
So basically, they're giving you this or something similar, and they're asking you, okay, they're giving you this part, and they're telling you what is f. That's what they're asking you. That's what they're doing. And it's just a weird question that I don't really care for. I won't test you on anything like that, but that's what they're doing.
Thank you. Yeah, okay. Like I said, it's just the notation. It's throwing me off.
Yeah, it's strange, but yeah, I wouldn't worry about it. Was there more like this one, or were they all like that? Your
No,
questions?
no. The next 3 were graphing.
We can do one more. What was the next one?
Let's see. This one I got, and I got a wrong answer. So let's go for one that I'm just very, very screwed. 15. Describe the x values at which f is differentiable. Let me show you. I don't know if you have the same one or not.
Sure, go for it.
Here we go. The screen. Sure. This.
Okay, so look at the question. The square root x plus 4.
Mm-hmm.
There is no issues with this function. If you were to see, let me try and think of a good way to explain it. The places you cannot take a derivative are usually like a really sharp peak, like if it's like literally like a triangle spike, or a really strange shape. But these are just basic functions. There's nothing wrong with them. Also, they're continuous and they have no holes. So the fact that it's just a regular smooth function means you can take the derivative anywhere on this function. So the question becomes, where does the function start? Where does it end?
Okay.
So that would be the answer. The derivative is everywhere this function is defined. So -4 till infinity.
Okay. I guess so I think where I ended up screwing myself is -4 to.
Yeah, put a bracket on the -4.
Okay. -4 to.
Is that a bracket? It looks like a second set of parentheses.
Oh yeah, whoops. -4 to infinity.
Yeah, I would delete that other parentheses though.
It doesn't work. That's what I tried, where you put a bracket, -4.
There we go.
Oh, you put the parentheses around it. Why the parentheses?
Interval notation. It's a habit.
Yeah, it's not supposed to have parentheses, but I guess it's cool with it.
Yeah, well, it's interval notation, marking an interval on a graph.
Yeah, the interval
did ask for.
The interval would be bracket -4 to infinity. It wouldn't be bracket and parentheses. It'd be like this.
Oh, okay.
It's supposed to be like, this is the answer.
Mm-hmm.
Parentheses over here, and then bracket over here.
Well, when you put sometimes it doesn't. Plus, sometimes it doesn't always sometimes it doesn't always do that.
I'm surprised it accepted it, but that's good.
Yeah, that's how I ended in, and it was wrong.
Okay.
And I couldn't think of any other way to try it. I tried multiple different ways. But I didn't
Okay, so that's how I screwed it up.
Strange. Yeah. Hold on a second. -4. If you plug in -4, it's still defined.
Mm-hmm.
Yeah, I guess, I mean, technically, I think it should be this, but they prefer a closed interval. The answer key is saying to do this. I'm not completely on board with that, but to get your answer correct, just put parentheses on both sides here.
Yeah, sometimes it screws me with it. I don't know why.
It
I
might
don't know
it
why
might want
it
a
likes to.
close set, not a or an open set. It might just be weird.
Yeah. Yeah, I don't know. Sometimes it makes me, yeah, sometimes it'll take it with or without it. I don't know why.
Yeah.
Okay.
Anyway,
So
Professor, what did you move for this week from last week?
I moved pretty much everything. Let me check for you here.
Okay.
I think all
Yeah,
of
I
chapter
think
2
you-
and 3. I just went ahead and made them all due this week, this Sunday, I think, or Saturday.
Friday.
Yeah, I don't remember, but
You
I
made
believe
the
you.
test due Sunday.
Let me see.
So we still have till Sunday, this coming Sunday for test.
Yeah, if you need it, you're welcome to take it on Sunday, and if you already took it, and I sent you an email saying you can take it again.
Okay.
But I'm only going to grade one of them, so if you're happy with your grade, leave it alone.
I'm far from happy with my grade. I plan on studying a fair bit and trying it again.
Yeah, I recommend if you felt like you didn't do well. I mean,
According to
you
the
do it again.
grading queue, mine's somewhere in the 40s. So
But again, I mean, I haven't graded it, so it's not like you know your grade, but you should have an idea of how much you understood it. So if you
yeah,
understood
I did have a question about 9 and 10 on the test. I thought they were a bonus question.
yeah, there's last two are bonus, I think.
Okay, because on the rubric of beforehand, when you had it broken down, it said they were both 15 points each, and then the other one was 70 points.
I can't hear you very well, but yeah, I'll make sure those are when I actually grade it by hand and I input your grade. Those will be extra credit.
Okay, gotcha.
the only other problem I'm stuck on in 3.1 is problem number 14. That would pretty much solve the last of my bit, because I think I can do the last of this piecewise function now that I understand where I went wrong on 15.
On that guy, you just find the domain of the function, and that will be your interval.
Okay.
Just find
I
out
think
where
I already did that.
Graph it and find out where it's defined, and that's it.
Okay. I think I had that written down somewhere.
Anybody else have questions?
I had a question on number 16 for 3.1.
Okay. Let me find
So
it.
not a question, but more like, how do you work that one out? What am I doing?
Yeah, this is pretty much similar. Here, let me show you the one I have. Is similar to yours or no? Kind of.
Different numbers, but yeah.
So it comes down to the same question, like where's the function defined, right? So from negative infinity all the way to 0 is this first function, which is the top part. And they tell you right here too. When x is below 0 or equal to 0, your function looks like this, a parabola. And then after that, it shifts to a different function, which is a upside down parabola going this way. So this function is differentiable everywhere because there's no strange kinks or spikes. I think the book calls them cusps. And there is no discontinuity. So if it's smooth with no holes in it, then it'll be differentiable. But as soon as it skips, it's no longer differentiable there because it's not defined there, right? So I would say it's you can find the derivative anywhere before this point, anywhere after, but they don't include that end point. You see that?
Yeah.
So you just say negative infinity up until that point, and then union everything after. That's what this is saying. In other words, the domain of this function is where it's differentiable.
Okay. I guess just seeing how they have the answer input kind of makes sense because they're wanting each of the points. Okay.
Exactly. Here, let me see if I can find a note for you. But excuse me, I'm trying to figure out there's a definition you can use, but that's pretty much the gist of it, though. 3-1, right? This is 3-1, correct?
Thank you.
What's that symbol in between it?
Where?
Between the two intervals.
Oh, this is a union symbol. They're uniting two separate intervals together.
Yay, I found my notes and found the domain. Yes, I did get it right when I actually worked it out. I just didn't realize when I hit it. Okay.
Cool. That's
I
good
just
then.
got confused because it was 3 lines. Okay.
So there is a nice theorem in the book. If f is differentiable at a particular point, then that means it is continuous at that point. Here's an example where it's not differentiable. You see that sharp corner? Oops, where is it? There. The triangle right here. Triangle looking shape. See that pointy part at 2? Let me actually close this stupid thing. 1 second. Here we go. I can see it better now. So this is differentiable everywhere except at 2 because it's a sharp edge. So this cusp is not differentiable.
Mhm. Okay.
And if you notice, the derivatives from left and right will be different, right? Because here we have a negative slope. Here we have a positive slope. So there's a change here. So what derivative would you have, right? If there's a sudden change, a sharp change or turn. Okay.
Okay.
All right. Make sure you also watch the videos. There's a lot of details in there I want you to look at. All right, guys. Do you have any more homework problems, or? Because I'm not gonna do 3-3 till next time. I'm gonna wait for that, so you can think about 3-2 for a while.
I don't have any questions.
All right. If you have no questions, you can head out, and I'll see you Wednesday. And if you do, I'll wait for you.
Okay, have a good night, everyone.
Have a good night.
Good night.
Bye-bye.
No.
I guess I just had a question since you said you're gonna move 3-3. Does that mean you're gonna move the date for the due date on that?
Yeah, I'm gonna keep adjusting because right now everything's kind of in the air.
Okay.
I will not adjust chapter 2 anymore, but I will keep adjusting chapter 3 for a bit.
Okay.
Okay.
Yeah, they say the cold weather might come back.
Yeah, I'll be ready this time.
I hope so. I'm only assessing damage, and I haven't started repairing a bunch of stuff yet.
Yeah, I'm almost done repairing, so been a pain.
Fortunately, most of the stuff that got broke is no longer useful.
I'm sorry about your trees, though, man. I like
Ah.
trees. It's a real shame.
Yeah, I do too. Yeah. Oh well. I haven't been able to set up a roadside stand in a couple of years. Last year it just spoiled, so it's not like it's that big of a deal. So they were pretty high producing. I was pretty proud of it.
Oh well. Maybe you can get a greenhouse or something.
Oh, I have greenhouses. I built them. I especially engineered them on skids and stuff so that they can, so I can actually tug them around and get them out of the way and mow around them.
Huh.
Since I have a creek-fed tank, it's natural water source. I use a hydraulic ram pump to pump it into a homemade 55-gallon barrel water tower. I have a fair bit of the engineering notation steps somewhere. I actually went around and actually applied hydromechanical engineering into it all.
It's cool, man.
So I'm hoping it could turn into a feather in my cap if I once I finish the rest of the ones, because it's actually not complete. The system isn't finished yet. I just got them last year.
Gotcha.
So, but I'm hoping once I finish them, if I could prove all the work I did, that might be a feather in my cap for in job and when I go looking for work.
I think so, man. I mean, if not, it's always good to talk about in interviews.
That's what I'm saying. Yeah, I have quite a few. My uncle even commissioned me to design him a trailer. So I'm working on that in CAD.
Let's see.
So
All right, Tyler. Well, I'm gonna watch some TV, finish eating, and call it a night.
yeah, I'm gonna
Hey.
finish my chapter in my book and I'm gonna head out.
You have a question,
I'm
Justin?
hit sec.
Yeah, I did.
What's
I was
up?
just wondering what so a score 100 on the test would be a 70, right?
Do you mean not including those last two questions? Or what do you-
Yeah.
Well, what I'm gonna do is grade everything by hand, and then just assign the actual grade in that module. So whatever it says, I'm gonna edit it with your real grade as soon as I'm done grading.
All right, and the test is still going to be available for an attempt, correct?
Yes, it's available until I think Sunday.
The 28th,
Okay.
yeah.
And once again, you're gonna grade before Sunday.
I'm not gonna start grading until everyone has taken it.
Okay.
So if you want to redo it, it's your decision. But I'm not gonna grade twice. So you would decide if you want to take it again.
Yeah. Okay. Well, yeah. I was just trying to get an idea of exactly what my grade was. So to determine whether or not I actually have to take it again.
I mean, if you feel confident, then I would say don't worry about it. If you feel like you could have studied more, then I'd say study more and take it again.
Yeah, whereas me, I kind of looked at my math as soon as I was done and realized where I screwed up.
Yeah.
So
Yeah.
Because it is a very theoretical test, so as long as you use your definitions and your reasoning was pretty good, then it should be all right.
Yeah. Yeah. Is it okay if I show you a question that just wouldn't submit for me?
Oh yeah, sure, man.
3.1. Yeah, I saved it in Paint. You can see it.
All right, let's see if it'll waiting for it to load. Okay, this guy.
that was one that had me stumped.
There's nothing wrong with it. I don't know. There's something weird in there.
Yeah, something doesn't quite look right.
Like, is there an extra comma somewhere, or is there an extra spacing in? Because the answer is right. I just don't know what the hell.
Well, it says the answer cannot be understood or graded. So
Yeah.
it can't be understood.
I say clear the whole thing and type it again because it's not wrong.
Because it looks like right there you almost have
Yeah, why is it floating up
your
there?
mouse. Yeah, it's like you have an exponent there or something.
Yeah, there's something in there that shouldn't be.
Okay.
Yeah.
Yeah.
Try retyping it real fast to see what happens.
Now I gotta redo it. Yeah. Okay. Well.
Yeah, just put negative parentheses, negative infinity to -9.
Yeah, let me.
I'll help you out. That's fine. Comma, -9. Now go move up with the union symbol.
It was in.
There it is. You pass it on sets.
Sets.
The bottom.
Yeah.
And then parentheses, -9 to 9, comma, of course. Parentheses, and then union again. Parentheses, 9 to infinity.
Yeah. Okay.
Should be good.
Yep.
Cross your fingers.
It'll automatically close the parentheses and let's see what happens. I hate that it jumps around.
Yeah.
There we
Sorry,
go.
I retried
Yay.
it 3 times. I swear. And,
Yeah.
That's
Yeah.
cool, man.
Like we said, there must have just been some weird character that you kept somehow entering or something.
yeah. Must have. I didn't highlight it all like that. Yeah. Backspace.
So you
Alright,
must have.
That's your only question, man?
Yeah. Yeah. Thank you. Yeah. Have a great night, guys. Thanks.
Good night.
Okay, see ya.
See ya, man.